Hello there, students. In this video, we're going to use the kinematic equations we derived in the previous episode to solve some example problems. For our first problem, a cyclist rides down a straight sidewalk with an average velocity, v bar, of 10 meters per second, which is about 22 miles per hour. What is their total displacement at the end of 10 minutes? Pause the video and take a minute to work this out. Alright, so to solve this one, we can use the first kinematic equation. We are given an average velocity and a duration of time, so we can plug those in. The only thing we have to be careful with are our units. We are given a velocity in meters per second and a time in minutes. With a quick conversion from minutes to seconds, we get an answer of 6,000 meters, or in scientific notation, that is 6 times 10 to the third power meters, which is about 3.7 miles. For our second example, a car is speeding down a road at 27 meters per second, which is about 60 miles per hour, where the speed limit is only 4.5 meters per second, or about 10 miles per hour, when they spot a cop ahead. Instinctively, the driver slams on the brakes to slow down. While braking, the car has an average deceleration of 4 meters per second squared. After 5 seconds, the driver passes the cop and stops braking. What is their final velocity after they stop braking? Were they still speeding? Pause the video and give this one a shot. Welcome back. To solve this problem, we can use the second kinematic equation. We are given an initial velocity, an average acceleration, and a duration of time for the acceleration, so we can use these to find the final velocity. Plugging these in, we have to be careful with the acceleration term. We are told it's a deceleration, so if we make our initial velocity a positive value, a deceleration means our acceleration term has to be negative. With that, we get a final velocity of 7 meters per second. We are given the speed limit is 4.5 meters per second, so the car is still speeding as it passes the cop. Whoops. Our third example is a bit more involved. An electric sports car can reach an acceleration as high as 16 meters per second squared, and can reach a top speed of 112 meters per second, which is about 250 miles per hour. How long does it take to reach the maximum speed starting from rest? How far has the car traveled in that time? And how far did the car travel in just the last 3 seconds of its acceleration? Pause the video and take a few minutes to try working this one out. Welcome back. There are many ways we can solve these problems. I'll highlight a few. To start, we are asked to find how long something takes, and we're given an initial velocity of 0 meters per second, since we're starting from rest, a final velocity which is the maximum of 112 meters per second, and an average acceleration of 16 meters per second squared. With this, we can use the second kinematic equation, where the only unknown quantity is time. We solve for time t, and plug in our other variables to find that it takes 7 seconds to reach the maximum velocity from rest, with the given acceleration. To find out how far the car traveled in this time, we can use either the first or third kinematic equation. Using the first equation and the mathematical definition of an average of the initial and final velocities, we find a displacement of 392 meters. Using the third equation, plugging in our given values for acceleration and initial velocity, making sure not to forget to square the time variable, we also get 392 meters. To answer the last part, we are asked about the last 3 seconds of its travel. This means its initial velocity in this time window is whatever its velocity was at 4 seconds, and the final velocity is its velocity at 7 seconds. We first need to find the car's velocity at 4 seconds into its travel. To do this, we look at the first 4 seconds of its travel, from 0 to 4 seconds. In this window of time, the final velocity is the velocity at 4 seconds, the value we're looking for, and the initial velocity is at 0 seconds when the car is at rest. The duration of time in this window is 4 seconds, so that is our time variable. Plugging this all in, we find the velocity at 4 seconds to be 64 meters per second, or about 143 miles per hour. Now we shift our attention to the last 3 seconds of travel, from the 4-second mark to the 7-second mark. We can once again use either the first or third kinematic equation to solve this. Using the first equation, plugging in our values, we find a displacement in just the last 3 seconds of 264 meters. Using the third equation, we of course find the same. This means the car traveled 264 meters in just the last 3 seconds of its 7-second trip. That's about 2/3 of its total displacement in less than half its travel time. Let's move on to our fourth and final example. In the sport of curling, a granite stone is pushed over ice to a target painted on the ground. If the ice provides an average deceleration of a bar equals 2 meters per second squared, and the player wants the stone to stop in the center, a distance of 36 meters away from the player, what must the initial velocity of the puck be? Pause the video and try to solve this one. Welcome back. To solve this one, we can use the fourth kinematic equation. We are told we want the puck to stop at the target, so our final velocity needs to be 0. We're given the displacement and the average acceleration, so we can solve for the initial velocity, plug in our variables, once again making sure that our acceleration term has a negative sign, since we've given our displacement a positive sign that dictates our positive coordinate direction. Taking the square root of both sides, we find the initial velocity has to be equal to positive or negative 12 meters per second. If the target is in front of you, in the positive coordinate direction, then a negative velocity here means you've slid the puck behind you, away from the target. So while this negative 12 meters per second is a valid mathematical answer, it's not a valid physical answer, so we ignore it and take only the positive solution of 12 meters per second. Thanks for watching and learning about physics. If you have any questions, please leave a comment on the video or on my Facebook page in the video description.